NEC section 695.6 addresses the sizing of conductors supplying fire pumps. The code mandates that the conductor size must be no less than the sum of 125% of the full load current of the fire pump motor or motors and 100% of the associated accessory equipment. This requirement ensures that the conductors can adequately handle the normal operating current of the fire pump system, including the motor and any auxiliary devices. However, a common question arises regarding the relationship between the conductor ampacity and the rating of the overcurrent protective device, or OCT, particularly when the OCT is sized to accommodate the motor's lot rotor current. The answer is no. The conductor does not need to be upgraded to have the same ampacity rating as the OCT in this scenario. The reason for this lies in the specific purpose and design of the overcurrent protection for fire pump circuits. Firstly, the NEC permits the use of overcurrent devices sized to carry the locked rotor current of the fire pump motor. This is a deviation from the standard motor protection rules, which typically aim to protect the motor against overloads. Fire pumps, however, are considered critical life safety equipment, and their reliable operation during a fire is paramount. Secondly, allowing the OCT to be sized for the locked rotor current prevents nuisance tripping during motor startup. Fire pump motors draw a significantly high inrush current when they start, often several times their full load current. If the OCT were sized too closely to the motor's full load current, it would likely trip during the startup, rendering the fire pump inoperable. Thirdly, the conductors are sized to handle the continuous load of the fire pump system. While the locked rotor current is a high magnitude current, it is also a short duration event. The conductors are selected to carry the 125% of the motor full load current plus 100% of the accessories, which is sufficient for the continuous operation of the fire pump under normal and fire emergency conditions. Fourthly, the overcurrent device protects the conductors from sustained overloads and short circuits. Even though the OCT is sized to allow the locked rotor current to pass, it will still trip in the event of a sustained overload in the conductors or a short circuit fault. This protection ensures that the conductors are not damaged by excessive current flow. Fifthly, the NEC provides specific rules for the protection of fire pump circuits to ensure reliability and prevent unnecessary interruptions. These rules take into account the unique requirements of fire pump systems and prioritize their continuous operation during emergencies. Sixthly, consider the practical implications of requiring the conductor ampacity to match the OCT rating. In many cases, this would necessitate the use of significantly larger conductors, which would increase the cost and complexity of the installation. Since the conductors are already sized to handle the continuous load, the additional expense of larger conductors is not justified. Seventhly, it is important to note that the NEC also requires additional protection measures for fire pump circuits, such as ground fault protection and phase loss protection. These measures further enhance the reliability and safety of the system. Eighthly, the installation must comply with all applicable requirements of the NEC, including those related to conductor ampacity, overcurrent protection, and grounding. Proper installation and maintenance are essential for ensuring the reliable operation of the fire pump system. Ninthly, consider a scenario. Imagine a fire pump motor with a full load current of 100 amps. According to NEC 695.6, the conductors must be sized to carry at least 125 amps, which is 125% of the motor full load current. The OCT, however, may be sized as high as the locked rotor current of the motor, which could be several hundred amps. In this case, the conductors would be sized based on the 125 amp requirement, and the OCT would be sized to allow the motor to start without tripping. Tenthly, remember to consult the specific requirements of NEC 695 and other applicable sections of the code for detailed guidance on fire pump installations. The NEC is a complex document, and it is essential to have a thorough understanding of the code requirements to ensure compliance and safety. The key takeaway is that the conductor ampacity does not need to match the OCT rating when the OCT is sized for locked rotor current. The conductors are sized to handle the continuous load of the fire pump system, and the OCT is sized to prevent nuisance tripping during motor startup while still providing protection against sustained overloads and short circuits. Understanding the specific requirements of NEC 695.6 and other relevant sections of the code is crucial for ensuring the safety and reliability of fire pump installations. This nuanced approach to conductor sizing recognizes the critical life safety role of fire pumps and prioritizes their uninterrupted operation during emergencies, while also ensuring the overall safety and protection of the electrical system.